The subject of fake 3D tends to be a bit of a contentious one in the world of GameMaker because, among other reasons, it tends to be a lot more work than real 3D, and it also, believe it or not, tends to perform a lot worse than real 3D. Nevertheless, sprite stacking is an ever-popular visual style, and because people are constantly asking me how to do it, I figured it's finally time to make a video on the subject. Hello all the crazy people out there, my name is Michael, I like Wizards and Dragons and making games, and let's talk about sprite stacking. I really wanted for this video to record a bit of me in the supermarket where I just like pick up a case of Sprite and stack it on top of something. But the last time I went grocery shopping, I completely forgot, and I'm not going to go back just for the sake of the joke. Anyway, so my sample project is basically an empty room with a player Sprite at this moment. And I just have like, this isn't even 2 frames of animation this time around. This is just 1 frame of animation. Alright, fine. It's a still frame that goes left and right. And I've also got a series of sprites, which we shall be using for sprite stacking when we get around to implementing the effect. So what is sprite stacking? So sprite stacking is a way of creating the illusion of 3D without actually doing anything in 3D. And before anyone gets any funny ideas about going down into the comments and saying something to the effect of all 3D is an illusion, you're just taking a bunch of mathematical points and projecting them onto a screen, no. For the purpose of having a productive conversation about computer graphics on the internet, that is real 3D, and sprite stacking is not. Anyway, to understand what sprite stacking is, imagine you have a real physical 3D object like, I don't know, a vegetable. And if you imagine cutting that vegetable up into a bunch of thin slices, and if you took those slices and layered them on top of each other, with each layer being, I don't know, 1/4 of an inch or so higher than the last. This has been my favorite video to make, by the way, because I got to play with my food. You could kind of sort of create a 3D representation of your vegetable when viewed from overhead, even though you're just looking at it from a flat angle. Now, this metaphor does sort of fall apart if you do it in real life, because I can't slice these pieces of bell pepper infinitely thin, so they do actually still have depth of their own, but in computer graphics, a 2D sprite has no such thickness to it. And that brings us back to these sprites. So, I've got a couple of these. This is from, by the way, if these look familiar, you might have seen Gizmo 199's Fauxton project. These sprites came from there, and I think he said he got them from a project called Magic of Voxel. So this one here is meant to represent a tent, and it's been cut up into 16 slices, and each of them you can imagine is a very thin slice of the tent as we go higher and higher up from bottom to top. Another way you could think of these, perhaps, is if you've ever had to prepare like a microscope slide. And if you've ever had to slice up a specimen to put under the microscope into like a very thin sheet so that you can put it on the slide and allow light to pass through. That's kind of what each of these sprite slices is here. And we've also got 2 trees, 2 slightly different looking trees, and they're the same deal. They're somewhat bigger. This one has 76 slices to it, and this one has 68 slices to it. I'm going to be writing some code to make the tent turn into an interesting sprite slice first, and then we'll get to the trees. So let me go create myself an object in GameMaker. We can go create obj stack. And my computer's freezing for no reason. Alright, so I'm going to go into the draw event, and I'm going to, let's make the font size somewhat bigger. We can start off by saying draw sprite. Our sprite can be just our sprite index, our image index can be, I guess I'll just make it 0 for now, our x and y. I'm going to assign sp_tent. Thanks. I'm going to assign sp_tent as the sprite index to this obj_stack here. Let me just go stick one in the room. That's the sprite. I'm going to go stick the object in the room, and if we run this, I think everyone has a pretty good idea of what this is going to look like. Okay, so this is just a single sprite. It's not that exciting. It's the first frame in this sequence of sprite images, and it's not really doing anything all that interesting. Now, if instead of drawing just the 0th sprite image index in the sprite, what if we were to instead say for of our I equals 0, I is less than image number. Image number, for those unfamiliar, is a variable shorthand for basically the number of sprite images in the current sprite index. It's the equivalent to doing something like sprite get number sprite index, which would just return the number of frames in an image index. Image number is something that you can use if you're just using regular GameMaker sprite indices. Anyway, when we draw the sprite, we can instead draw the sprite at some image I instead of 0. And if we do this, congratulations, we are basically drawing the tent from above, except instead of drawing a single sprite, which is, for all we know, all that we can see right now, we are drawing 16 sprites, which is maybe not the best way to draw what we just put on the screen there. So what if, instead of drawing all of these sprites at the exact same position, what if we were to offset these by some amount? So remember how when I was doing the visualization with the vegetables and like sliding the slices of pepper up by a small amount? Well, we can do that by adding a little bit, or I guess in our case, subtracting a little bit from the y-axis. So I'm going to subtract I from the y-axis as I draw this. This will just make it so that the first sprite index is going to be drawn at position xy. Index 0 is drawn at position xy. The index 1 is going to be drawn at position x and y minus 1. Index 2 is going to be drawn at y minus 2, and so on. And we are going to run the game, and we all of a sudden have something that looks a little bit more like a 3D tent object, even though we are just drawing the same sequence of sprites, and even though the sequence of sprites is just literally going to be 2D slices going from bottom to top, we have something that can sort of pass off as about a 45-degree angle, if you were to imagine looking down at the scene at a 45-degree angle. And if I were to zoom in and editing, you can see some additional fancy features such as the tent poles. You can see they have a little bit of height to them. The flap on the tent. You can see the shape of the flap on the tent. And you can even there's like 2 pixels on the screen that are like the sleeping bag or whatever that is on the inside of the tent. And this might not be the most convincing 3D effect, but if you let your imagination fill in some of the gaps, you can sort of see how we're creating a 3D looking object just by using the sequence of 16 sprites. So this actually isn't where this effect gets really interesting. So where the sprite stacking effect does get really interesting is where you start to add rotation. So it's worth pointing out that the sprite origin for all of these images is the middle center. If you don't put the sprite origin at the middle center and you try to rotate them with sprite stacking, it gets a little bit weird. You usually will want to rotate these things around the origin. Otherwise, you'll have to do a bunch of annoying math to compensate. So I'm going to say, let's have, over time, we're just going to rotate this object. And we can say, I'm going to say var rotation is going to be current time divided by 100. Current time, for those who have never seen it before, is a built-in variable of GameMaker, which just measures the number of milliseconds since the game has started. So it'll go up by 1,000 every second. If I divide that by 100, it'll go up by 10 every second. So this is going to rotate at a speed of 10 degrees per second. If you wanted it to go a little faster, maybe you could say divide by 25, so it's going to be 40 degrees per second. And now I'm going to say draw sprite extended, and this is going to allow us to put in a rotation. X scale is going to be 1, Y scale is going to be 1, rotation is going to be rotation, blending color is C underscore white, and blending alpha is going to be 1. And this is going to cause the tent to rotate on the spot, and if we look at this, and I'm just going to let it play for a few seconds, we can see that the 3D-ish effect is now slightly more convincing than it was a few minutes ago. And at certain angles, you can even see the sleeping bag inside the tent flap for just like a couple of frames as it passes by. And we have, in effect, created something that looks a lot like a low-resolution 3D object using nothing but 16 sprite slices. Alright, so that's pretty interesting. So, once you've gotten a handle on this effect, there's a couple of further questions you might start to ask, such as, what happens if you try to scale this up by some amount? I'm actually going to scale it up by 4 so that you can see the problem that I'm about to express a little bit more easily. Let me go and just insert the scale variable into the drawSprite extended function. And if I run the game now, we're going to see that we still have a bit of a 3D tent effect, but it suddenly looks like we're coming down from a much more overhead angle. And the reason for that is because despite having the sprite slices themselves scaled up, the amount that we are offsetting each slice by is still the same, is still going to be just 1 unit of world space up for each sprite slice. So mathematically, kind of what we're doing is we're looking down at the scene from an angle that would be like the arctangent of 4/1, which I want to say is like an 80-degree overhead angle, whereas if it was 1-to-1, it would be 45 degrees. You know what? Because this is going to bother me if I don't look it up. What is the arctan? Really? Windows Calculator doesn't have an arctan? Alright, fine, we'll do this the old-fashioned way. $76. Alright, so we are looking at the scene from an overhead view of 76 degrees. So if we want to compensate for scale when you do sprite stacking, you should generally multiply your vertical offset by the scale of the sprites that you're drawing at if you don't want to have any funny camera angles like that. So let me run this now, and if I run this at a scale of 4 with the vertical offset having a step of 4, then we have once again the tent coming down from the same camera angle that we did before. It looks a lot more pixelated, as you probably can expect. Because we have a finite resolution to the sprite slices. If you wanted a more smooth, like less alias, less quantized look to this 3D object, then you would need more slices at a higher resolution. That's just the nature of the beast. And that introduces a second question that you might have, which is that if you wanted a lower camera angle, or maybe a higher one on purpose, could you multiply the vertical step of the sprite slices by some value larger than 1, and could you get a like a 30-degree angle or so by doing something like this? And the answer to that is kind of, but the problem when you do that is immediately obvious in that we've got sort of at certain camera angles a bit of a Venetian blind effect, because again, all this is a sequence of sprites that are stacked on top of each other. And if the quote-unquote camera angle, which is to say the vertical step, the vertical spacing of the sprites is too extreme, then the spacing in between sprites becomes a lot more obvious. And again, if you wanted something like this, you would need a larger sprite with more slices at higher resolution, which leads us into a bit of a problem with sprite stacking. So there's one more thing that I'd like to talk about before I get into everybody's favorite subject of performance, and I'm going to set the scale back to 2 so that we can fit a few more objects on screen without going insane. And I'm also just going to get rid of the extra like vertical offset stepping so that we don't have that Venetian blind effect. So if I run this now, I don't know why I ran this now because there's only like one object in the room. Let me go and add a create event to the obj_stack, and I'm just going to say sprite index is going to equal choose sp tent, sp tree1, sp tree2. So we're just going to randomly choose one of these 3 sprite sequences for us to draw in the room. And if I go into room 1 creation code, I'm just going to say repeat, let's say 100 instance create depth. The x can be a random position in the room. The y can be a random position in the room. Depth can be 0. And the object that we're going to instantiate can be obj_stack. And this is just going to randomly create 100 instances of sprite stacks in the room. And they're all going to have a different sprite stack model, if you will. So we've got the tents, and we've also got these trees. And these trees, as the tents do, have their own sort of quasi 3D look to them when they rotate on the spot like this. But you may notice that we have some sprites that are not being like stacked in a very nice way. For example, this tree over here is being drawn underneath the tent, so it looks like the tent has been pitched in the middle of the tree, and this tree over here is being drawn over the tent, and it looks equally wrong. And this is a classic depth sorting problem. The traditional way that you would deal with this in GameMaker is to do something like depth equals -y, or if you're hardcore, you could say depth equals -b box bottom. And that's probably the most famous line of code in all of GameMaker. I will not explain it now. I have made videos on it in the past if you're curious. If you're using real 3D, by the way, you can just use the depth buffer to sort this out, and you don't have to deal with all this, and it's very nice. Anyway, if you just do that depth equals negative y trick, that's going to do automatic depth sorting for us, and we no longer have tents being pitched in trees. And now we're going to move on to everybody's favorite subject of performance. So before I get into performance, I would just like to take a moment to remind everybody of the golden rule of software development, which is that
thou shalt not preemptively worry about performance issues.
As always, context is key, and there will be things that I say about sprite stacking that do not generalize to all GameMaker games. And because misinformation on performance in GameMaker games is rampant on the internet, I would like you to all be considerate of that fact. Now, with all that said, sprite stacking is actually kind of uniquely inefficient. We frequently tell people in the GameMaker community to not preemptively worry about performance issues, but the fact of the matter is that people actually do run into performance issues when they are doing sprite stacking a lot more frequently than they do when they're making other kinds of games. And the reason for that, I think, should be fairly obvious. So, when you're making an ordinary game in GameMaker, drawing your sprites is pretty straightforward. You will draw generally one sprite per object. Maybe if you're doing some kind of fancy effects, you'll draw 2 or 3 sprites per object. However, when you draw sprite stacks, you will find yourself frequently with, in the case of this SP_tent here, 16 sprites per object. In the case of SP_tree1 here, 76 sprites per object. And if you have a large number of stacked objects on screen at once, you will frequently find yourself drawing a lot of sprites very quickly. So if I were to, let's say, show debug overlay, I'm going to enable the debug overlay so that we can see some performance data when we run our game. And I'm also going to increase the number of instances created from 100 to 500. This is a bit of a stilted example because you generally won't have this many instances this close together. But if you have an entire level and every object in your level is drawn as a series of stacked sprites, you might find your game slowing down a lot more quickly than you would if you made your game with some other style. Or, as I said at the beginning, if you were to actually use real 3D. So this looks a little bit silly because we have this many. All right, you know what? To make this look a little bit less silly, let me set the scale back to 1. And we'll have 500 tree and tent objects, which are all rotating on the spot. The rotation doesn't really make that much of a difference here because GameMaker sprite rendering is kind of good at that thing. It's not a real like 3D rotation matrix or anything. But we can see that with just 500 of these sprite objects, we are down to, on my computer, 80, 90 FPS. And this computer is not exactly new and cutting edge anymore. But you generally would expect that it could do a little bit better than that for just 500 sprite objects. And the reason for that is that if we were to go into run the game in debug mode, so click the icon with the bug in the top of the IDE, or you can hit F6. If you run it for the first time, you'll be asked to allow it through the firewall. If you go to the profiler, you could dig a little bit deeper. Where is the profiler? In the others tab, you could dig a little bit deeper into exactly where where all the time is going when you're doing this. And if we see this, if we let the profiler run for a little bit, if we go into the draw event of obj stack, we can see that we are drawing 28,000 sprites per frame. 28,000 sprites per frame is a lot. That's going to be an average of, I want to say, like 50 sprites per object. 28 divided by 500 is 56 sprites per object on average. And that adds up. As always, when we talk about performance, you can generally get away with more on desktop than you can if you're making a game on mobile. There is some wiggle room on exactly how much logic is too much, depending on what you're doing. Again, context is everything. But if you do attempt to make an entire game out of stacked sprites, you can see how this adds up a lot faster than if you were to make an entire game out of basically any other graphical style. So there's a couple of things you can do about this. I'm not going to get into general GameMaker optimization here. For the most part, when you're making a game, you won't have this many objects just sitting on top of each other like this. They will be spread out throughout the level. It would be highly recommended that you only draw objects that are actually on screen. GameMaker will, to some extent, perform sprite culling for you, but that only affects the geometry that's sent to the GPU for rendering and not the objects that are actually being processed in the draw event. It would also not be a bad idea to not have sprite stacks that are 60, 70 frames long if you can avoid it. I think the reasons why that is are pretty self-explanatory.
Hey.
But as it turns out, that's actually only half of it. The reason that I say sprite stacking is uniquely inefficient as a graphical style is that, in addition to, GameMaker is fairly famous for being a generally CPU-limited engine. For the most part, when you're making games in GameMaker, you're just drawing sprites, you're not making any fancy high-fidelity 3D levels, you're not using any fancy Unreal Engine 5 shaders or anything like that. The actual drawing of the sprites is pretty simple, and as a result, GameMaker games will generally work fine on computers with even a fairly old iGPU, as long as the CPU can keep up. But sprite stacking manages to hit both the CPU and the GPU fairly hard. The reason that it's expensive on the CPU is fairly obvious. We just spent 5 minutes discussing that. The reason that it's expensive on the GPU is a little bit more involved and a lot harder to work around. Because the reason that it's a problem is kind of integral to the whole way that sprite stacking works to begin with. It's known as overdraw, for those of you who know what that is, and I would actually like to make a separate video on that, where we have a look at that using a different graphical effect, because I think that would be a better way to put it in proper context. I definitely don't want to make it sound like this is a bad style and that you should never use it. I don't really care for it myself. I don't really like that ultra low resolution 3D look that it creates. If that's the style that you want to go for in your game, then go for it. But if you do choose to go for this graphical style, it is important to know what you're up against, and also do seriously consider that your life might actually be a lot easier if you just did real 3D. And on that note, I guess the last thing I'd like to say about this is that you can actually combine this with real 3D to do some interesting things. I don't really want to spend that much more time making videos on sprite stacking, except for one, like, tangentially related subject that I'll probably get to soon. But if you're really committed to it, feel free to just experiment, play with other camera angles, play with, I don't know, whatever else comes to mind, and see if you can make anything interesting happen. So with that, my name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the GitHub repository down in the description of the video. If you want to learn how to do real 3D in GameMaker, I've got, like, I don't even know how many videos on 3D in GameMaker on my channel that you can go and have a look at. I also make videos on other stuff in GameMaker, so if any of that appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found there as well. I hope you all found this interesting, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Manta Ray, Ganymede Ghosts, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you'd like to join their ranks, head on over to the Patreon page down in the video description to join the fun.